Hello and welcome back to another episode of the Hidden Quantum Champions. Today we are looking at a company called QEDMA, so QEDMA, which is active in the space of error correction and error correction software. So if you are interested in this, then make sure to stay tuned, get yourself something to drink, and let's get ready to dive right into it. So before we talk about what QEDMA is actually doing, let's maybe talk a little bit about the idea of quantum error correction. So today we have the first actually working quantum computers, right? So there are quantum computers with tens of qubits that can actually be used to run some types of algorithms. However, these are so-called noisy intermediate state quantum computers, so NISQ systems. What does that mean? Well, these qubits, they're actually physical qubits, so they are atoms or they are superconducting circuits that behave like these two-level quantum systems where it can be 1 or 0, like in a classical bit, but of course with these quantum properties on top of it. However, they are not perfect. So unlike in our computers where it's always exactly 1 or 0 and it can only, and the gates that are running on top like AND and NAND and OR gates, they are working perfectly well, or can be assumed to work perfectly well if you're programming the computer. And this is not actually the case for the quantum computers today. So there will always be some error, and there's some so-called error mitigation schemes. So you can measure the system, understand its properties, and hence kind of tune your signal so it functions better. But there are also errors that you cannot avoid. Like, for example, when cosmic particles hit your quantum processor, they might impact the signal. And this is actually something that is quite complex because as we are creating states like superposition and entanglement, if we entangle multiple of those qubits and let's say cosmic particle hits your qubit number 2, because it is entangled to all of the other qubits, this will also affect all the other qubits. It affects the whole quantum state. And therefore, this whole idea of quantum error correction is a whole science in itself. It is a complicated subject, and it is actually something that is currently being investigated and researched on. However, it is not only a theoretical idea, because recently, within the last couple of years, there have been multiple cases where people showed that they could run, let's say, the very low-level error correction schemes, error correction algorithms on their existing hardware, and hence combine multiple of these physical qubits into what we call one logic qubit. So the logic qubit is then error corrected and basically run stuff with these error corrected qubit. Now, with that context being given, let's dive into what QEDMA is actually doing and how they are contributing to this. So here it says QEDMA enabling the quantum computation revolution, the ultimate suite of error handling solutions for the quantum ecosystem. So our mission, QEDMA's mission, is to push the world towards quantum algorithmic advantage by developing software products which enhance the performance of quantum computers. We aspire to provide products that are powerful, valuable, and easily integrated into existing hardware across all quantum computing platforms. So hardware agnostic software solution, and here we basically see the whole stack. So you have the quantum processor, could be, for example, a superconducting one, could be neutral atoms, could be photonic, could be ions, spin qubits, whatever you want to think, right? Then you have the controller sitting on top of that is running basically on or is creating the control signals and so on to run the quantum processor. On top of that, you have the characterizing error suppression. So that is part of this, error mitigation as well. Well, error suppression, then you have the error mitigation on top. You have the optimization, and then you have the quantum algorithm design. Okay, so mitigation is not the same as error correction. So let's see, maybe they're only here, like looking at this, I would assume that they are not building quantum error correction, but that they are in this mitigation layer here and the optimization layer. So let's see if my assumption at the very beginning was wrong and that we are looking at something that is optimizing NISQ systems, but not yet at the point where it's running error correction on itself. So solutions allowing your quantum computations to achieve their true potential, detailed and efficient characterization of noisy QPUs, quantum processing units, error mitigation for any algorithm, enabling maximum quantum circuit volumes. Circuit volume means basically both being able to kind of write algorithms that spread across the whole chip, right? Like entangling, but then also deep algorithms, as in running multiple gates after each other, so that you basically reach, if you are looking at both dimensions, a bigger volume. That's more or less the idea, right? Then top-notch speed accuracy trade-offs, reliability, verification, stability, robustness, high accuracy results from noisy devices, and then cross-platform solutions. So looks like we are not talking about error correction here, but that we are in the error mitigation, which is also what is relevant in today's NISQ system still, because error correction reduces your number of qubits quite a bit. So you want to try to, let's say, run as much mitigation as possible at the beginning so that you get most out of the hardware. And then once, let's say, the qubits are scaling further, then the error correction becomes more relevant. So QESEM, QESM, error reduction software. Current quantum computers are too noisy for implementing useful quantum algorithms. QEDMA's quantum error suppression and error mitigation QESM solution transforms an algorithm designed for error-free quantum computers into one that can be executed with high accuracy on today's quantum computers. Characterization software, so high-precision detailed characterization of multi-qubit systems, is essential for improving the design of quantum processors and reducing errors in existing quantum computers. QEDMA's characterization protocols, working with unprecedented speed to accuracy trade-off, extract the errors occurring during each operation, quantum gate or full computational layer of the quantum device. Experimentally tested and verified QEDMA's characterization software provides a flexible cross-platform tool for quantum hardware developers across a variety of platforms, providing all key error parameters in real time and unrivaled speed accuracy in an easy access and user-friendly way. Quick thing about that. So we have talked about similar companies that are, let's say, in the characterization part of the stack before. If you haven't seen the video, make sure to go check out our Hidden Quantum Champions playlist on the YouTube channel. On top of that, of course, we have here this whole idea of error reduction, which kind of adds to that. Now, why is this such a complex topic? Because in the characterization phase, you want to basically be able to understand the system at, let's say, minimum overhead, and that requires quite a bit of understanding, quite a bit of, let's say, crafting on the algorithms. And then, of course, in the mitigation or in the error reduction part, you also need to be able to kind of play this out and then translate these algorithms so that where the system might be very inaccurate, you are basically not relying on the accuracy of the system. But yeah, that's maybe, let's say, the top level view. Then we have the news article section down here. Last one is Israeli quantum startup QEDMA just raised 26 million with IBM joining in. We quickly look into this article here on TechCrunch. Maybe not. I don't know why it's not allowing me now to... now it's entering. So this is from July 2025. I'm recording this in May 2026, so it doesn't seem to be fully up to date. Then there's some information here about the team. So you see QEDMA team is considered outstanding worldwide. Both CSO Professor Dorit Aronov, and CTO Professor Nita Linder, who are also co-founders, stand as internationally rewarded figures in their respective fields, with tens of years of experience in all relevant areas and stands of world leaders in quantum computation and in the physics of many systems, quantum, I guess. Furthermore, QEDMA boasts an extraordinary team of personnel with diverse and cross-disciplinary background. The research and application teams comprise not only the foremost few computing researchers in Israel, but also global leaders. Collaborating closely with these teams in the development team, which includes uniquely skilled software engineers with a strong background in Israel's premier technology firms and a history of service within the top technology units of the Israeli Defense Forces. Notably, all team members hold degrees in physics or computer science from Israel's finest universities. And then we have here the, let's say, founding team, and I guess some accreditation here of, let's say, their prior working places or universities that they have been working with. Let me quickly hop into the software part of it. So QEDMA's error reduction software, QASM as an overview. So the main problem of today's quantum computer QPUs is noise, consisting, for example, of decoherence and calibration errors. These effects significantly deteriorate the accuracy of the output of already very small quantum algorithms run on current devices. To address this issue and enable effective use of quantum computers today, QEDMA has developed QASM, a world top quantum error suppression and error mitigation software for current QPUs. QASM enables users to obtain highly accurate results from their quantum algorithms, even though these algorithms are being run on the current available QPUs, which are very noisy. With QASM, customers can scale up their quantum algorithms and achieve accurate outcomes from incomparably large quantum circuits compared to the circuit volumes that are possible to run without error mitigation or with competing error suppression and mitigation methods. QASM already produced accurate and provably unbiased output as the largest circuit volumes to date. By this, QASM brings customers significantly closer to practical quantum advantage for their computational problems of interest. We anticipate that very near future improvements in quantum hardware in tandem with QASM will enable circuit volumes that surpass those which can be simulated using classical algorithms and hardware. And then, of course, after that, like once you have reached this state, you might also come to a point where you can run useful things that you cannot run anymore on a classical computer. Then here's something about the workflow. So given a set of quantum circuits to be run, a set of observables to be measured, a required statistical accuracy, and a QPU time allocation on a practical QPU, QASM first compiles the circuits onto a set of quantum logic operations available on the QPU. These include natively available operations as well as additional operations calibrated by QEDMA available on selected QPUs. QASM then efficiently characterizes errors in circuits composed of these quantum logic operations. Based on this characterization, QASM recompiles the given circuit into a set of circuits to be run on QPU and estimates the required QPU time. Once all circuits have been run and measurement outcomes have been collected, QASM implements classical post-processing and reports an estimate and an error bar for each observable. And then here you have the workflow, right? Main attributes. So QASM is unbiased, so QASM outputs unbiased estimations for expectation values of observables. Estimation errors are predominantly statistical and can be reduced in a controllable manner by allowing additional QPU time. So large volume accurate output, unparalleled trade-off between circuit volume, classical accuracy, and QPU time, unattainable by competing methods and software packages. Scalable QPU time depends on circuit volume, but is otherwise independent of the number of qubits. Application agnostic, applies to any quantum circuit and observable. Reliable QPU time estimation. QASM reliably estimates expected QPU time both before and in the beginning of each run to support users in managing their quantum resources. Gate level or pulse level access. So gate level access to a QPU suffice to obtain cutting edge results with QASM. Pulse level access allows for further boost in performance. Pulse level is then basically what you send to the qubit, right? And with that You can also tune, let's say, and improve the error rates in the system by using statistics and kind of fine-tuning your pulses. And then support for a variety of state-of-the-art hardware platforms. So QEDMA supports has already been demonstrated on QPUs based on cross-resonance and tunable coupler superconducting qubits, as well as trapped ions by leading quantum hardware manufacturers. Demonstrations on additional hardware platforms is ongoing. Target audience of QEDMA. So QEDMA is intended for developers and users for quantum applications, software or hardware who are interested in running quantum algorithms on quantum processing units today and receiving unbiased noise-free results at circuit volumes which are otherwise inaccessible with cutting-edge statistical accuracies and QPU times. Target audiences include research groups in university and research centers working on quantum algorithms, quantum many-body physics or quantum chemistry, data centers, high-performance computing centers which have incorporated QPUs into their classical computing hardware, and enterprises that are actively developing quantum algorithms aligned with their core business challenges and are interested in becoming quantum ready and working towards applying quantum algorithm to achieve return on invest. That's basically about the technology. Then as per usual, also a little bit about the company. So QEDMA's team is considered outstanding worldwide. Both founders who are co-founders stand as internationally rewarded figures in their respective fields with tens of years of experience in all relevant areas of quantum computation and a stance of world leaders in quantum computation in the physics of quantum many systems respectively. Furthermore, QEDMA boasts an extraordinary team of personnel. Our research and application teams comprise not only the foremost quantum computing researchers in Israel, but also global leaders. Collaborating closely with these teams is the development team, which includes uniquely skilled programmers with a strong background in Israel's premier technology firms. Notably, all team members hold degrees in physics and computer science from Israel's finest universities. We've seen that before, right? So at QEDMA, we believe that gender balance is extremely important. QEDMA has particularly emphasized this aspect in leadership roles with 50% women representation in its top management. QEDMA intends to soon improve its gender balance across all levels of positions. Achieving gender balance is not only a matter of equality, but also a strategic imperative of QEDMA, ensuring it will enhance our ability to adapt and innovate by bringing diverse perspective and experience to the forefront. For our gender equality plan, see here. And then we see the, let's say, top level management of the company, and I guess that's about it. The company is based in Israel. I think we've seen that before. And that's basically already everything I wanted to share with you in today's video. So QEDMA is a company that is working on, let's say, error mitigation and improve or error suppression. So they're working on the software layer or on the algorithmic layer that runs on top of existing quantum computing platforms. It runs both on superconductive and on trapped ions. The company is based in Israel, and they are basically helping you to get more out of your existing quantum hardware in a time where error correction is not yet implemented on practical systems. I hope you liked this video, and I'm looking forward, if you liked it, to see your thumbs up and also to see you again in the next video. If you have any other company you would like me to kind of check out for you, let me know down in the comments below. I'm very excited about that. And looking forward to see you in the next one. Until then, bye-bye.